All right, the last two problems, both story problems. I'm not going to read the whole problem. You can look at it while we're doing it. 34, the size p of a certain insect population at time t in days obeys the function. Story problem, but they give you the equation. Let's write it down, and then we'll see what everything means. 700 times e to the 0.03 t P is the number of insects, T is the time in days. So this is function notation, P of T. So basically saying here's an equation for P, and it's going to have a T in it, and there it is, 700 times e to the 0.03 t. So P is the number of insects. So the first question, how many insects at time 0, 0 days? Put in 0 into your equation. So P of 0, 700 times e to the 0.030. What's 0.03 times 0? 0. What's e to the 0? 1. That's why we call the 700 the initial value. It's always the answer when the time is 0. So here's the answer to part A. B, they say, what's the growth rate? There's no math to do here. What happens when you have a problem where you have E, you have the natural exponential function, the growth rate is whatever is in front of the T, although growth rate is usually as a percent. This is 0.03, so I think they call the growth rate 3. So it's like you do the opposite of percent. If I said 3% growth rate, then you put in the equation 0.03. Now they're saying my equation is 0.03. What's the percent growth rate? You say 3. 3, and the answer is percent. C, all right, rolling along. What is the population after 10 days? So what's that mean? P of 10 equals what? P of 10 means the time is 10 days. What's the population? So we take the equation and put 10 in for T. So grab your calculator. 0.03 times 10 ends up being 0.3. So 0.3 exponent on E times 700. And they say round the answer to the nearest whole number. So I get 944.90. So I think to round it to the nearest whole number, 945 insects. Now they say, when, for part D, when will the population reach 980 insects? Now they're saying T equals what for P equaling 980? So you got your equation. Put in 980 for P. Now we're trying to solve for T. This is an exponential equation. I'm going to eventually solve this by using logs, but the first thing you have to do is, before you take the log of both sides, you've got to get the exponent by itself. So I'm going to divide both sides by 700. I'm going to go ahead and just see what this equals. 980 divided by 700, 1.4. Now I'm solving for t. The t is up here in my exponent. I'm going to take the log of both sides. Now in this case, it just makes sense. Since I got an e here, I'm going to take the natural log of both sides. You'll see why in a minute. So natural log of 1.4, natural log of e to the... So first of all, exponent can move down front of the log. Now what is natural log of e? Remind you, natural log you can think of as log base e. So what's log base e of e? It's just 1. So really what I have is natural log of 1.4 equals 0.03t. If I solve for t, so I grab my calculator, and they say, here's the answer, but they say approximate it to the number of days. Approximately 11 days. Oh, they say to the nearest tenth, sorry, 11.2 days. That's D, and then E, when will the population double? Let me rewrite our equation. T equals what for population to double? Well, let's think about what's the initial population. We actually calculated that. Or we can do it again. The initial population was time is 0. When you put a 0 in for t, you get p equals 700. Remember, p of 0 is 700. So if it were to double, what's the population when it doubles? Well, if it starts at 700, when it doubles, it's going to be 1400. So let's put in 1400 for P and solve this thing for the time. This is the amount of time. This is the initial amount. If it doubles, it's this amount. This is just like the last problem. I'm solving for t. Divide both sides by 700. End up with this. I'll take the natural log of both sides. The exponent comes down here. And actually the natural log of e is 1, so it's this. Solve for time. Time is natural log of 2 over 0.03. And it probably says round to the nearest tenth. Looks like 23.1 days. All right, as problems go, that was not too bad. Finally, the last problem on this review. Number 35. Another story problem. A mathematical model has been developed based on data from space shuttle launches involving the relationship between the Fahrenheit temperature X. So maybe I'll write this down. So the temp, they're calling X. Temperature X around the O-rings and the number Y of a rotor leaky O-ring. So the leaky O-rings is going to be Y. And then they give an equation that relates the leaky O-rings based upon the temperature. They say Y equals, and this is really sort of an ugly equation, 1 plus E to the negative, and then parentheses, 5.085 minus 0.1156x. Wow. But the key is there are two variables in here. There's Y, which is the number of leaky O-rings, and X is the temperature. So in other words, you choose a temperature, you plug it in here, do the calculation, and that will predict how many leaky O-rings you have. So part A, what is the predicted number of leaky O-rings at a temperature of 90 degrees Fahrenheit? So I'm going to plug in 90 degrees Fahrenheit and say, what is Y? So basically it just becomes sort of a nasty calculation. 6 over 1 plus E to the negative 5.085 minus 0.1156 times 90. All right, got to know how to use your calculator well. For me, I'm going to take 0.1156 times 90 equals, I'm going to make it negative because I'm going to subtract it from 5.085. Take that whole thing and I got to reverse the sign, and that gets raised to the e power. Then I add it to 1. Then that whole thing goes on the bottom times 6. Hopefully, if I did it correct, and it says type a whole number. And I got 0.029. Looks like to me, when it's 90 degrees, there are approximately zero leaky O-rings. And that's actually correct. Now for part B, they say do the same thing, except now see what happens when the temperature is 20 degrees Fahrenheit. So instead of rewriting this whole thing, I'm just going to plug in 20 in for the 90. So that's 20 times 0.1156 plus 5.085. Then that whole thing is made negative. And then E plus 1, that goes in the bottom, times 6. I get 5.647. Which if I round it, looks like it's saying we're going to have 6 leaky O-rings. Then they say, find the graph of the equation. So they basically want you to graph this equation. It's almost like we have 2 points. It's almost like X and Y. The first point, we said when the temperature was 90, the leaky O-rings was 0. That's point 1. And point 2, when the temperature was 20, the leaky O-rings was 6. So we have 4 choices of graphs. Let's see if we can tell these 2 points should be on the graph. So let's zoom in a little bit. Let's see if we can look at these. So I'm looking, first let's see about 90, 0. X 90, Y 0. So X 90, Y 0 here and here. This one is definitely not correct. This one's not correct. So now I've narrowed down to this and this. My second point is 20 and 6. 20. Now, it's not exactly 6. So this is 20 up here. This is 20 here. I could see, my guess is maybe it's B, but I wonder how I'm supposed to know for sure. I guess if I look, my extra calculation was 5.647. So if I go to this graph, let's see if I see which one's closer to 5.647. Here or here. Actually, this right here is 5. So this to me looks like around 5.5. Looks to me like it's probably B, which I think is the correct answer. A little bit hard to tell. If you wanted to know for sure, you could actually take like the number 50 and plug it in, because the 50 is here and the 50 is way up here. You should see the difference. But moving on, and the very last part, at what temperature is 5 the predicted number of primary O-rings? Now they're saying, for part D, they're saying, how about what is the temperature that will give us 5 leaky O-rings? So we're going to take our, we're going to take our initial equation, and now I'm going to plug in y equals 5 and calculate x. So I'm going to put in 5 for y and calculate x. So this is going to be 5 equals 6 over 1 plus e to the negative, in parentheses, 5.085 minus 0.1156x. Solve for x. Wow. In order to solve this, I've got to get this exponential by itself. First thing I'm going to do, now this is going to be messy. Multiply both sides by this whole parenthesis down here. So I have 5 times 1 plus e to the negative 5.085 minus 0.1156x equals 6. So let's actually divide both sides by 5. And then let's subtract 1 from over here. So now I finally have e to the minus 5.085 minus 0.1156x equals 6/5 minus 1. It's going to be 1/5. So now I have the exponential by itself equals a number. Since it's e raised to a power, I'm going to take the natural log of both sides. So over here I end up with just my exponent equals natural log of 1/5. Let's multiply both sides by a negative. Let's subtract 5.085, negative 0.1156x equals negative 5.085 minus natural log of 1/5. Let's divide this whole thing by negative 0.1156. So all these negatives cancel. So basically I have natural log of 1/5 plus 5.085 equals divided by 0.1156. And it says round to the nearest degree. I got 30.06. So basically 30 degrees Fahrenheit, which is the correct answer. All right, that math was sort of ugly. But anyways, all right. So that is the last problem on the homework review. So hopefully this will help you understand some of these problems you're having difficulty with.